this thing. All right, so last time we talked about solving quadratic equations. We saw how we can solve using okay, can we take it earlier? So the thing is, the reason why we're going to use the CUNY first time, because that's what has been designed for us to take it at, and it's going to be a 2-hour exam. So that's why we're going to take it on the 24th, because we can't do it right now because at this time slot, because everyone has different schedules. So I can't do a 2-hour exam for the final, and the finals should be 2 hours. And will the final be available all day, or will it be a uniform time? Yeah, it's going to be a uniform time. So it's going to be the time that CUNY first has specified. So I don't know exactly what time. I don't know if it's it might be from like 11 to 1 or something like that. But it's a 2-hour exam. Yes, the exam will be cumulative. That's the idea. The exam will be a cumulative final. So it's on everything. So everything that we covered in test 1, test 2, and everything after exam 2. So, okay. So it's going to be cumulative. It's going to cover everything. And that's why maybe that extra week will be helpful. Okay. So lecture number 21. So we talked about quadratics. We talked about how to solve them using square roots, how to solve them using factoring, of course. And then we talked about completing the square. And then we left off on the quadratic formula. So I would like to do one problem using the quadratic formula. So solving quadratic equation. Again, the quadratic equation is bulletproof. It works under any circumstances. Solve quadratic equations using the quadratic formula, using quad formula. So let me give you one. Hold on 1 second. Yes, so I'll do one like this. So here we have an example. If I got 4x squared minus 4x equals 7. So here we have a quadratic. And the first order of business, right, when we have a quadratic that looks like this, I want to set it equal to 0. So I got 4x squared minus 4x minus 7 equals 0. And now look what form I have it in. What's the form? The form is ax squared plus bx plus c equals 0. So I can say the following. I can say that my a value is in front of the x squared, which is 4. My b value, which is in front of the x term, is negative 4. And my c value, which is a constant, is negative 7. So these are the a, b's, and c's. Once I have that, I can use my formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I just have to plug in the correct b value, a value, and c values. So this is negative 4, because b is negative 4. So I have to be careful with the negative, the parentheses. Plus or minus, then we plug in negative 4, we square it, minus 4 times a, which is 4, multiply it by negative 7. And we divide this whole entire thing by 2 multiplied by 4. And then we know that negative of negative 4 is positive 4, plus or minus the square root. Negative 4 squared is 16. Negative times 4 is, so negative 4 times 4 is negative 16. And 16 times, negative 16 times negative 7 is 112, and it's positive 112. So this would be positive 112. And we're going to divide that by 8. So this equals 4 plus or minus, and then when you add it, when you add 16 plus 112, you get 128, and you divide it by 8. And then we try to see is, wait a minute, 128, I think I can break that down, right? How can I break down 128? Is there a perfect square that divides 128 nicely? So we can think about it, right? It looks like 4 goes into it. 128 divided by 4, that works. 32. But actually, there's a bigger one, 128. So let's do that. Why don't we do that? Why don't we do 4, square root of 4? If you do square root of 4, this would be 32. This would be 2. But I can break down 32 further, right? I can break it down with 16 and 2. So 16 becomes what? 2 times 4 rad 2. This becomes 8 rad 2. So 128 is actually the same thing as saying 8 rad 2 over 8. Okay? And then what do I notice? I notice that I can factor a common factor in the numerator. I can factor a 4 out of the numerator. I get 1 plus or minus 2 rad 2 divided by 8. And now the 4 and the 8 can be canceled. This becomes 2. So my answer becomes 1 plus or minus 2 rad 2 all over 2. That is my x. Those are my x values. I have a positive version of it, and I have a negative version. So another way I could write this as my roots, right? I got the first root being 1 plus 2 rad 2 over 2, and I got the other one being 1 minus 2 rad 2 over 2. Okay, and so that's how we apply the quadratic formula. If we know our A, B's, and C's, we just replace all the A's, the B's, and the C's in their respective places, and then we perform PEMDAS pretty much, and we make sure that we can try to break down the radical, if possible, as much as possible, and simplify as much as I can until I get my simplified answer. Okay, so that's solving quadratic equations. Okay. Now that we can solve quadratic equations, we have no trouble really with solving it. Let's look at what other information we're able to get from quadratic equations. So we're going to be particularly interested in graphing quadratic functions. So the graphs of quadratic functions are what we're going to be interested in. So we should know, right? What do we call the graphs of quadratic functions? What's the shape of a graph of a quadratic? What kind of shape does it give us? Have you everyone seen what a graph of a quadratic looks like x squared, for example? Like as an example, right? We got y equals x squared. This is like the simplest kind of quadratics. We get something like this, right? we get a parabola. So the shape of a quadratic function is a parabola. Is called a parabola. So all the shapes of a quadratic are parabolas. And sometimes we have parabolas that open upward, and sometimes we have shapes of parabolas that open downward. So this, for example, if I do this, if I do y equals negative x squared, then I'm going to have the same graph. It's just that it's going to be upside down, right? So one thing we're going to have to figure out is how do we determine whether it goes up, whether it opens upward or opens downward? So we do that by looking at, what is it? So either it can have a max or a min, right? So this has a minimum and this has a maximum. This one here kind of looks like a valley. This one here looks kind of like a little hill. So how do we determine whether between a max or a min? So when does the parabola or the graph, when does the graph of a quadratic have a maximum, which means it opens downward, or a minimum, which means it opens upward? And the answer is very, very simple. It depends upon ax squared plus bx plus c. It depends upon the sign of the first leading coefficient. So it depends on the sign. Depends on the sign of a. So what happens if a is positive? If a is positive, then what? Then my graph is going to look something like this. Then my parabola opens upward and has a minimum value. So if my a value is positive, opens up. The other scenario, if my a value is negative, so if I get like a -3 in front or whatever number that has a negative sign, then the parabola opens downward. And it has a max instead. So I would have something like this. So these are my two scenarios. These are the only scenarios that really happen that we're going to be concerned with parabolas. Either my a value is positive, opens upward, I have a minimum, right? I have a minimum. Or I have the a value being negative, opens downward, and I have a maximum. So this is what happens with parabolas and how I'm able to determine whether it's up or down just by looking at the sign of the x squared term. So for example, if I give you y equals negative 5x squared plus 7x plus 3 versus y equals 100 x squared plus 5x plus 10, which one of these has a max? Which one of these has a min? Which one of these opens up? Which one of these opens downward? So which one of these opens up and which one of these opens downward? Is the left one up or down? So on the one on the left, guys, what do we know about the a value? What's the a value here? Negative 5. That's my a. So is the a value positive or negative? Well, it's negative because it's negative 5. So I know that's going to be negative. If it's negative, is it opening downward or upward? The left will be down. Very good. Yes, that's right. So we would have an opening. So this opens downward. And not only that, this has a max. So it's going to look like a little hill with the maximum point somewhere. And then if you notice here, my a value is 100, but it's positive. So that means that it opens upward. If it opens upward, then it has a minimum. Okay? So one of them opens downward, has a max. Other one opens upward, has a min. And that's as simple as it gets in terms of determining whether something goes up or down. Okay, so once we have that understanding, let me see something. Once we have that understanding, there's another thing that we also should think about parabolas. Parabolas have a nice shape, right? They go up and then go down. But also they have what's called symmetry. And what we're going to need to know is what's very important about parabolas. It's called the axis of symmetry. So there's a line that divides every parabola straight in half. So this axis of symmetry is a vertical line that goes through the vertex of a parabola. So the vertex is either the maximum or the minimum point. So it's a max or min. It goes through the vertex of the parabola and divides a parabola into two equal parts, or halves, I should say. That's the axis of symmetry. And there's actually a formula for the axis of symmetry. The formula is the following. You find it by knowing what B is and dividing it by 2A. That's the formula. And if you observe, this formula looks very similar, reminiscent of the quadratic formula. We also have negative B, right? And over 2A. It's just that we had that whole plus or minus square root stuff. But if you look at the first portion of the quadratic formula, it's actually the axis of symmetry. And the axis symmetry is very useful, especially when we talk about the graph. When we talk about the graph. And not only is it going through the vertex and dividing the parabola into two halves, this is actually, the axis symmetry represents actually the x-coordinate of the vertex. So when you plug in the values for B and A, you find the line, the vertical line that goes through the vertex of the parabola, but also you also represent the x-coordinate of that vertex. So if I know the vertex, the x-coordinate of the vertex, I can find a y-coordinate. So an example. An example would be y equals negative x squared plus 4x plus 1. Okay? So I have an example of parabola. Who can tell me, does this open upward or downward? Just by looking at it, without even having to graph it. What do I know? What does the number in front of the x squared tell me? I have a negative what? I have a negative 1. This indicates that what? This indicates that parabola opens downward. And I know that the parabola has the max as a result. What would be the, so from here, what can I figure out? I can figure out what the A value is, what my B value is, what my C value is. I can find the constants, right? Or the coefficients. So what are my coefficients? -1, 4, +1. Those are my coefficients. And then under the formula, what would be the axis of symmetry? X equals -b over 2a. So then what is x? -4 divided by 2 times -1. I get -4 divided by -2, which equals 2. So what is my axis of symmetry? It's the line x equals 2. That's it. It's the vertical line x equals 2. But not only that, remember what I just said? This represents the x-coordinate of the vertex. So how do you find the y-coordinate if you know the x-coordinate? I know my equation, right, is -x squared plus 4x plus 1. So now to find the y-coordinate, I must plug it in. Y equals -2 squared plus 4 times 2 plus 1. And then I get what? I get -4 plus 8 plus 1. -4 plus 8 is 4 plus 1, that equals 5. So I found the y-coordinate of the vertex. So then what are the coordinates of my vertex? What are the coordinates? Well, the x value is 2 and the y value is 5. So if we put this all together into a graph, into just a sketch, of course, just a sketch. If we sketch it out, what do we know? We know that at 2, I have I'm gonna write it as a dashed line. I have the axis symmetry is x equals 2. And I know that also represents the x-coordinate of my vertex, but my y-coordinate, It's 1, 2, 3, 4, 5. Right here. That's that point. This is my vertex, right? My vertex is 2, comma 5. And what else do I know? I know that that vertex is a max. If it's a max, that means that this must open downward. So I'm going to have something that looks like this. That's going to be a sketch, of course, of my original function, quadratic function. Negative x squared plus 4x plus 1. I know that the axis of symmetry is x equals 2. So that line goes vertically and it goes through the vertex and it divides the parabola into 2 halves. And I know, as along with the axis of symmetry, I know that the coordinates of my vertex, which is the maximum, I know that that vertex is 2, comma 5. And then if I have a sketch, this is what the sketch of my graph looks like. Is that understood? Any questions about the axis of symmetry? Any questions about determining if it opens upward or downward? So that's a lot of information already about the graph of the quadratic. Knowing if it opens upward or downward, that's one thing. And knowing what the coordinate is of that max or min is another. Now we need 2 more things, and we're able to give a good sketch for any graph. Oh, and one thing I forgot. So from here on out, we also are concerned not just with the way it looks, right? But we're also concerned with the domain and the range. So here again, we talk about the domain and range. So what would be the domain of any quadratic? Because my quadratic keeps on going down and downward as you move to the right and to the left, your domain for quadratic functions is always negative infinity to infinity. Now, what's the range? The range are all the y values. So we have to look at the y values, and in this case, the largest y value here is 5. That's the largest y value, but you can't go anything above 5. You have to go but you have to go below 5 instead for the graph. So the range is everything from negative infinity to positive 5, and we include 5. We include 5. So we should also be able to determine the domain. In this case, it's always going to be negative infinity to infinity for quadratics. But the range is going to depend upon if it opens upward or downward. And it's going to depend upon where the vertex is. What's the y value of the vertex? Okay, so we're going to keep that in mind. Okay, so now that we talked about the axis of symmetry, the vertex, maximum, minimum, domain, and range, we need 2 more things to really give us everything we need to be able to graph a good sketch of a quadratic. And those are the x-intercepts and the y-intercepts. So the y-intercept is very simple because this occurs when the x value equals 0. Literally just plug in the 0, x for 0, and find y, and that will be your y-intercept. And normally when you have, for example, y equals ax squared plus bx plus c, if I plug in 0 for x, I get everything cancels out, right? This cancels out, this cancels out. And what I get is c. So actually c represents, this is the y-intercept. The c value represents the y-intercept. So the y-intercept is actually, can be rewritten as as the coordinates 0, comma c. So for example, over here, the y-intercept here would be what? The y-intercept here would be 0, comma 1. So this graph is not accurate. This actually should cross 1 instead, not at 3. So this actually crosses at 1. So I can figure out the y-intercept pretty easily. What takes me a little bit more work, obviously, is the x-intercept. The x-intercept's possible, right? There could be more than one. The y-intercept is only 1, but there could be more than one x-intercept. So that means that your parabola could cross the x-axis more than once. And that's when the y value is equal to 0. And the x-intercepts are really what? They're also known as, aka, the roots of the graph. They're also known as what? The zeros, or the solutions. So to find the x-intercepts, those are the points where it crosses the x-axis, which is equivalent to saying, hey, find the solutions of the quadratic equation. So we should be able to find the x coordinates that make the graph cross the x-axis. So now when we have those points and we're able to put them all together, we can have a very nice sketch. So the x-intercept is found. So these are found by solving the quadratic equation. By using anything, any of the techniques, right? We can use factoring if possible. We can use square roots if possible. We can do completing the square method if possible. Or if you have a certain inclination to use completing a square, or you just use the quadratic formula. That's usually the standard way, right? So if you use the quadratic formula to solve for x, the x-intercepts. And that's why we studied how to do that first. So now we can apply it here. So let me give you one. Okay, let me give you one. Here we go. So I want to graph. So sketch a graph of y equals 1/2 x squared plus 2x minus 6 by finding the following. So I'm gonna try to break it down. So this is kind of like the checklist to sketch the graph of a quadratic. So the first thing is I want to determine max or min. So determine max or min, which is the same thing as saying opens up or down. Opens up or down, right? That's the first thing. So determine whether that what's what. The second thing is find axis of symmetry, which is the same thing as saying find the x coordinate of the vertex. So once we find that, we can find the y coordinate of vertex. And once we have the x-coordinate and the y-coordinate of the vertex, we got the vertex. The fourth thing is find the domain and range. Establish what the domain and range is. The fifth thing is find the y-intercept. The second thing is find the x-intercepts. And then the seventh thing is put all the things together and sketch graph. So these are all of the little items that you need to be able to find to give a good sketch. Okay, so yeah, so before we do that, actually there should be like a step right before this. So you can call this like 1A, this is 1B. You should find the coefficients first. Find the A, B, C coefficients. So then everything else kind of falls into place. So you need to find the A, B, and C's. So that's the first order of business here. What is the A's and the B's and the C's? So then the A here, what do I get? I get that the A is equal to 1/2. I get that the B is equal to 2. And I get that the C is equal to -6. So that's important to highlight. That's the first thing I can actually get without much issues. So who can tell me if this has a max or a min, if it opens up or down? So what happens with this one? Does it open up or down? Does it have a max or a min? And how do we know? Anybody out there? How do we determine whether we have a max or a min with our parabola? It has a minimum, Sierra. How come? You're right. It does have a min. And what's the reason why it has a minimum? If it has a minimum, then it opens upward, right? And how do you know that? It has a min?
It has a positive coefficient in front of the A.
Very good. So this is positive. The A is positive. Okay, good. So we established that. And then we found A, B, and C. Okay, good. So far we checked off 1A and 1B. Now, what's the axis of symmetry? In other words, what is the x-coordinate? What must we do? Use the formula, right? X equals -b/2a. I know what my a value is. I know my b value. So this is -2 divided by 2 multiplied by 1/2. Be careful. It's 2 multiplied by 1/2. 2 times by 1/2 is 1. And so we get that x equals -2. So what we found is the x-coordinate of the vertex, also known as the axis of symmetry. Done. So step 2, done. Step 3, how do you find the y-coordinate of the vertex if I know the x-coordinate of the vertex? What must I do to find the y-coordinate? If you have the x-coordinate and you have the equation of the graph that you're dealing with, how do you find the y-coordinate? What must you do? You must do what?
Plug in the value of x in the equation.
Very good. So let's plug that in. So y equals 1/2, and then you plug in -2 squared plus 2 times -2 minus 6. Negative 2, when you have that parentheses around it and you square it, you get 1/2 multiplied by 4. This equals negative 4 minus 6. 1/2 times 4 is 2 minus 4 minus 6. So 2 minus 4 is negative 2 minus 2 minus 6 is negative 8. So I know that y equals negative 8. I know that these are the x and y coordinates of my vertex. So then what's my vertex then? My vertex is what? My vertex is negative 2 comma negative 8. Great. So I know that this vertex is also a what? I know this vertex is a minimum. So it's a minimum value. The vertex is a minimum. The axis of symmetry is x equals negative 2. So the domain, can I figure out the domain? Actually, let me change this. Dotted paper, square paper. Yeah, let me change this to a graph. Okay, so let me start plotting the points that I have. Let's see what is so here we go. I'm gonna draw the axis real quick. So this is 1, 2, 3, 4, 5, 6, 7, 8. This is 8, and this is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, negative 8. 1, 2, 3, 4, 5, 6, 7, 8, negative 8. This is the y-axis, this is the x-axis, this is the y-axis. Okay. And so then, so far, what I have is x equals what? Negative 2. So I'm going to put this with the dashed line here, negative 2. So this here, x equals negative 2. This is the axis of symmetry, right? And then at 5, 6, 7, 6, 5, I have my vertex. Negative 2 comma 5. That's my vertex. Wait, what am I saying? Why did I say 5? I don't know. I must have thought about the previous answer. Okay, what I meant to say is negative 8. That's what I meant to say. Negative 8. So I'm right here. This is my vertex. My vertex is negative 2 comma negative 8. Okay, so far this is what I have. Okay, and I know this is a minimum too. So this is a minimum. Make sure you highlight that fact. It's a minimum. So if it's a minimum, then that's the smallest y value that it can get. Now, what would be the domain? The domain is always going to be negative infinity to infinity, all real numbers. What's the range? That's the one that changes all the time. So what would be the range for this parabola, knowing the fact that the vertex is negative 2 comma negative 8 and it's a minimum? What would it be? How would you express it? Anybody have an idea? Remember, the range only deals with the y value. So the y value, they're saying that the smallest one is negative 8. If that's the smallest one, then everything else, all the y values will be above negative 8. So the range is including -8 to positive infinity. So this is the smallest. So I have the domain range. What's the y-intercept? The y-intercept is found by looking at the C value. That's the y. Pardon me, the y-intercept. So this would be what? 0, -6. 0, -6 is right here. I got 0, -6 as my y-intercept. So far I'm good. Now, what's the x-intercepts? That's the last thing. Once I have this, then I can sketch it. So how do you find the x-intercepts? I'll put it over here. What about the x-intercepts? I got 1/2 x squared plus 2x minus 6. I have to set it equal to 0. And now I have a quadratic. How do I deal with this quadratic? How do I solve this quadratic, guys? I have A, B, and C, right? So I can use a quadratic formula. I could. Or I can try to play around with this and see what happens. I don't like this 1/2 in front of it. You see how I have the 1/2? If I multiply everything by 2, what happens? When I distribute the 2, I get what? I get x squared plus 4x minus 12. That equals 0. So when I multiplied everything by 2, I did not change the solution of the equation. I just changed the way it looks. Because from here, what can I do? I can factor. And what does x squared plus 4x minus 12, what does that factor into? What multiplies to -12? That adds up to +4.
+6 and -2.
That's right. +6 and -2. And so then now I can solve for each, right? X plus 6 equals 0, and I got x minus 2 equals 0. So I got that x equals 2, and I got that x equals -6. And these are my x-intercepts now. So what are my x-intercepts? -6, 0, and 2, 0. So I got those two. And now I can plot them, -6, right? I can plot them. So I have 2, zeros over here. That's 2. I got -6 here. And now look what happens when I sketch it. When I sketch it, it's going to go through here. It's going to go right through here. And of course, it changes, alters it a little bit. So yeah, it's not going to work. So I'm just going to do it freehand. So guys, this is what I get. This is my sketch. I have a minima. My y-intercept is 0, -6. I got my x-intercept here. 2, 0. And I got this other x-intercept here. -6 comma 0. So this is what's gonna happen on the final exam, right? I'm gonna include one of these kind of problems with quadratics, and I want you to label. When I say label, this is what I mean by label. I labeled everything. So this is the sketch of the graph with everything labeled. I got every point here labeled. I got the axis of symmetry labeled. I got the max. I mean, in this case, the min, the vertex. I got that labeled. I got it labeled with what it is, right? It represents, each of these points represents something different, and each of these lines represents something different. So I'm able to label them with what it is as words, and then I'm also labeling it with the coordinates. Give me 1 second, guys. My battery's about to die. Hold on 1 second. Through the whole time. Hold on. Before you guys just disappear from me. Okay, we're good. Crisis averted. Okay. All right. So yes, look how beautiful this is. It's beautiful, right? Quadratic equation. Now it's graphed. I got the points, the intercepts. I don't know what just happened. Hold on. Okay, great. Awesome. All right, good. Good. We can graph them. We can find the x-intercepts, the y-intercepts, and we're all happy. Check. So I sketched it. Okay, so that's the idea. I found the domain as well too. Domain, range, everything's done. So this is what I want. This is what I want. This is what I expect from you guys when it comes to graphing and sketching quadratics. Yeah, and one more thing. This idea of the this idea of the y coordinate, the y coordinate of the vertex is also known as. So this is also AKA. It's either the max or the minimum value. Okay. The max or minimum value. So in this case, right, the maximum value of, because this is a max, the maximum value of this function is a 5. That's the maximum y value. In this case, in our case here, the minimum y value, so the minimum y value, so just note, the minimum value of the function is -8. So when we talk about the value, they usually refer to the y value. So what's the minimum y value? When you say the minimum value in this case would be the y coordinate of the vertex. The maximum value would be if it was a maximum, like in the previous example, right? The maximum y value or the maximum value would be 5. So that's just terminology that they like to use. Okay, all right. So now that we have this understanding of graphing, right? I want to talk about some applications that we can use. Some applications of what's called quadratic modeling. So the reason why we use quadratics, one good reason why we use quadratics is because there are certain things in in the world that behave parabolically. Most notably, right? Anything that's thrown into the world, anything that's thrown in our world, doesn't matter what kind of object, usually, right? A basketball or whatever. When you throw it, when you shoot it, it has a parabolic curve. So quadratics are essential to understand how things move in our world. So that's why it's very important to be able to understand and break down quadratic functions, because you can then use that to explain different kinds of motions of physical objects. That's one reason why we even talk about it. So for example, let's look at an example. The height h in feet of a rock thrown upward so the amount that thrown upward at an initial speed of 64 feet per second from a cliff 50 feet above an ocean beach. Is given by the following. It's given by this formula. H of t is equal to negative 16t squared plus 64t plus 50. And then we're t's in seconds, right? T is in seconds. Find the maximum height. That the height that the rock will attain, or that the rock will reach. Okay, so this is a scenario. Somebody's at the top of a cliff that's 50 feet above an ocean, and they just throw a rock, just randomly in the air with an initial speed of 64 feet per second. And so now they're asking us, find the maximum height of this rock, since the rock has this equation that represents the height with respect to time. This is a very simple, in a way you can talk about it, a physics problem, a simple physics problem that we can solve using quadratics. And a lot of physics problems deals with mathematics, like such. So I want to find a maximum already. I already have, I know it's a maximum. How do I know it's a maximum? That number in front, right, is negative. So I know it's going to be a maximum already. They didn't need to tell me that I have to find it, because I already knew it. And whenever we have such scenarios like this, we always want to draw just in case, right? Drawing just helps. So this is like the beach here. This is the beach. And then you have this cliff here, and this is 50 feet above. And then you're somebody right here, and you're throwing a rock. It's a pretty big rock. You're throwing a rock, right? And you're just throwing it upward. And that rock, the height of it, is given by this formula. And I want to find a maximum. So in actuality, the maximum height deals with what? When they say maximum height, and another way to say this, so mathematically speaking, What are we actually finding? We are finding the what? The vertex of parabola. That's what we're finding. The vertex of my parabola tells me the max. So to find the vertex, I need to do what? What's the first order of business? The axis of symmetry. So this step here is essential, the axis of symmetry. What is the axis of symmetry? X equals negative b over 2a. And normally what you should always try to do before you begin is to find what a, b, and c is first. So just get that out the way. That's the easiest thing first. So a is equal to what? Negative 16, b is equal to what? 64, and c is equal to what? 50. Plug in. I get negative 64 divided by 2 times negative 16. And I get negative 64 over negative 32. And if you divide this, what happens? This is exactly what? 2. So actually, in this case, it's not x, it's going to be t because my t is my independent variable. So make a note of that. This is my independent variable. Instead of x, we're using t in this case. So t is what? T equals 2. What does that mean? What does this mean in words? So now I have to learn how to interpret what we get. This is that after 2 seconds, so I should say, let's write it this way. The rock reaches its maximum height two seconds after it is thrown. So it reaches 2 seconds. After it's thrown, after 2 seconds, that's how high it gets. That's the maximum height. And then it falls down, comes back down. So then, how do we find that maximum? Well, it's like finding the y. So this is like my the x coordinate of my vertex. I want to find the y coordinate. I want to find the maximum height. So what do I have to do to find max height? I need to plug in, don't I? I plug in the point where it is the maximum height, which is at 2 seconds, after 2 seconds. So now I have to plug in. So I get negative 16 times 2 squared plus 64 times 2 plus 50. And I get negative 16 times 4 plus 64 times 2, which is 128 plus 50. Negative 16 times 4 is negative 64 plus 128 is 64. 64 plus 50 is 114. So what is the maximum height? The maximum height of the rock is 114 feet. And that's it. I did it. The maximum height of my rock is 114 feet in the air. Goes almost more than halfway than what it originally was. It's pretty high up in the air. Any questions about this? Does this make sense? Do you see how we can apply quadratics and apply it to real world applications? It makes sense to use quadratics to represent the height of any object because that's how our trajectory works. in our world, right? It's parabolic shapes due to gravity. And there's a lot of the physics behind that. Okay, so any questions? Everything, this is clear? So that's the maximum height, right? Now, according to this model, I can also figure out how long. So this is like a typical question. So after you figure out what's the height, the question now becomes, how long does it take? How long would it take the rock to hit the ocean beach or to land on the ocean beach? So I want to figure out how long. Now, if you're on the beach, how high up are you? What is the height if you're on the beach, according to this scenario? If you're on the beach, you're at sea level, right? Apparently. So you would automatically be 0 feet above, right? That would be your height. If you're on the beach, you're 0 feet above it. So the idea is I want to set my quadratic equal to 0. That's what I would do. Set it equal to 0. So this would be negative 16t squared, right? Plus 64t plus 50. Set this equal to 0. So I want to solve this. But there's a lot of stuff here, right? So A is equal to negative 16, B is equal to 64, and C is equal to 50. Factoring this will be, I could factor, what I could factor is actually, I can factor a, I think a 2 is enough. So I factor a 2, I get negative 8t squared plus 32t plus 25. That's the most I can do, actually. That's it. And then I could divide out the 2 if I want. And look what I could reduce. I can reduce the quadratic. So I can get a new ABC. A is negative 8, B is 32, and C is 25. But that's it. I can't do anything else. So T is equal to what? Negative B plus or minus the square root of B squared minus 4AC all over 2A. Plug in negative 32 plus or minus the square root of 32 squared minus 4 times negative 8 times 25 all over 2 times negative 8. It's a lot of numbers here. That's T though. So T is equal to negative 32 plus or minus the square root. And then whatever's inside the square root, I got 32 squared minus 4 times negative 8 times 25. I got 1824. So this is 1824 divided by negative 16. Okay, so let's be very careful here. I get 2 different t's, right? The t1 is when you add them. We get negative 32 plus the square root of 1824, and you divide it by negative 16, and you get the other one. T2 is negative 32 minus square root of 1824 divided by negative 16. So I'm going to do this individually. Okay, I'm going to share my calculator with you guys. Oh, wait, where's my calculator? So here's my calculator. I'm going to calculate exactly what I just wrote. So I got negative 32 plus the square root of 1824 24 divided by negative 16. And when I do that, I get negative T1 equals negative 0.669 dot, 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 dot. I'm gonna do the same exact thing, but I want to find, I'm gonna change the numerator. Whoops. Change the numerator. Instead of a plus, this will be a minus sign. And when I press that, I get 4.669. So I get two values. I'll share back. I get two values for t. So I have two solutions, right? One solution is negative, the other solution is positive. In the context of our problem, we're dealing with time, right? And particularly, we're dealing with time after you throw the rock. The rock is thrown. So it does not make any sense to talk about negative time. Negative 0.6 seconds. This has no bearing in our world. So we reject, quote unquote, we reject this solution because it doesn't make sense in our world. We can't talk about negative 0.6 seconds after I threw it. That doesn't make any sense. So the only number that does make sense is this. So nearly after 4.7 seconds, so after 4.7 seconds, the rock, after 4.7 seconds that the rock is thrown, the rock lands on the beach, on the ocean beach. So nearly double after it reaches, right? More than double. So it reaches a height, a maximum of 2 seconds, and then you almost have it more than double. Yeah, you more than double that time, and you almost have 5 seconds. So 4.7 seconds later, it lands on the beach.